Hi, I'm Daniel Black. I'm the Chief Innovation Officer at the MariaDB Foundation. It's a pleasure to be at linux.conf Australia here today, and especially talking about this topic of MariaDB and systemd and the integration of it. Just as a little bit of a backstory, this funding of the initial work of systemd capabilities into MariaDB all 7 years ago, was actually funded by the Open Source Developers Club. And so I'd like to, give a little belated thanks again for funding the work and actually getting me through a few months. But enough of the background. Let's start off with a demo, and where I'll actually go through the aspects of how to set up a multi-instance version of MariaDB with a per user configuration. Don't worry about taking notes, they'll be on the website beside it. And so enjoy the presentation. Thank you. Bye. I'm sure you've all seen systemd services before, but I'll just show you MariaDB service file, which begins with far too much documentation. Just go, documentation is cool. We see that it's a type equals notify service and has been since the 10.1 days. We see that it's got a user and group of MySQL there. We see it's got a bunch of capabilities. We see in the middle there that protect home equals true, which we're going to need to address because we're doing multiple instances in the user's home directory. And we've also got exec start read only equals true that we also need to address when we do our service. So for the more astute of you, will notice actually on your system there's already a bunch of templated services running by default, and these are denoted by the @ symbol in the service file. The element after the @ symbol is the instance name. And if we look at, say, the service file for the user runtime dir service, we see that it's pretty much the same, except it's got this bunch of %i's, which is the templated aspect, and there's numerous other variables, but for the most part, we'll just be using %i today. Now, MariaDB has had a multi-instance service for a while that was significantly improved in 10.4 and above, and that looks like this. So also begins with much documentation, and there's much more useful documentation here because there's a number of ways a user may want to run their multi-instance service, and we've included a number of ways to configure all these easily. We have set the baseline rather consistent with this MySQLD multi-instance environment variable, and that is used for not only the install DB but starting it also. Once we've got those two consistent, we can pretty much got a reliable system in that way. There's a number of MariaDB system variables or command line options that by default will actually conflict if you try to run more than one instance of MariaDB in your system, and they are the socket, the port, and the data directory. Our goal here was to run an instance per user, and that means that the socket and the data directory are quite easy. We can just run those in a user's home directory. The port number is a little bit trickier. One way of doing it is to map the user ID of the user and use that as the port number. On my system here, like the default user ID is like 1,000, which is less than 1,024. So we're going to need to do a little bit of a trick here to get that. To make the deployment of this a little bit easier, what I've got here is a little template file of the configuration that we're going to plop into every user's home directory that contains the user port and the socket and the data directory, the conflicting items. Well, the user isn't conflicting, but let's put each on their own user for just manageability. Now integrate this into systemd by in the service file, and we're going to do the system control edit MariaDB.service and actually add an override file. This is a bunch of options that override the default configurations, so it should be fairly minimal. We've got our user group both set to %i, such that it's a user of the system. We've removed the protect home privileges. We've also removed the start only, permission start only, so all our exec pre scripts here don't actually run as root. As before I mentioned, the MySQL D multi-instance environment variable is used by the MariaDB install.db and starting of the service, and we to make it consistent. Our exec pre line here is if the configuration file doesn't exist, we crudely use sed as a pseudo templating tool to create the my.cdf file if it's not already there. See the trick that we did with the port. We grabbed the user's ID, added 3000 to it in a little bit of bash arithmetic, and that's used for the port number. In our MariaDB install.db, we notice we're using a root authentication mechanism of socket and a root socket user equivalent to the username starting the service. And we do that for the security to ensure that the Unix user has to be connecting to the socket for it to be authenticated properly, and I'll show an example of that later. We skip the testDB here. It's not only the testDB, it's also the anonymous user that we typically don't want. Because a user on the command line could just go shut down and it will effectively shut down the service, we put a restart always here so the service starts up if they happen to do it, just to save some support calls. If we daemon reload as user, I haven't worked out why this does it at this stage. We look to see what files are there. There's no sockets there, and just to show that there's no my.cnf there by default. So if we start our service, MariaDB at dan.service, you can see within a second or so it's started. And if we look at the status, you see it's up and running. We've executed all our prescript. We've got a main PID. We've got a status of taking your SQL request now. So we may as well. If we look at our files there, we see it's created those socket files. And in our configuration file, that one's also been populated. So let's connect. MariaDB is the client thing. Utility as a monitor. See it connects there. We do \s to show our current connection. We see the current user is Dan at localhost, not surprisingly. We also see down the bottom that the Unix socket is home dan/mariadb.soc. If we show grants, we can see that we've got all privileges on star.star with a grant option. So we've got all the privileges of what's normally a root user. We've authenticated using the Unix socket. However, the MySQL native password authentication is still there. However, it's got no password hash currently, so that bit's disabled until we actually set a password. However, for the most part, it's more secure this way because once we set a password, another user on the system could actually access this account using the password. So it's secure in its default installation without a password set. So what about another user? Well, let's add Tom. Easy enough as a user, and we start their service. It takes roughly the same time. And if we look at the status, we see it's up and running with home/Tom as the configuration file. Yeah, and for the most part, it's identical. If we look at the MariaDB processes on the system, we magically see there's two. Remember when we looked at our home directory, we see that there's a MariaDB socket. Oops, we've created that with global read-write permissions. So this means our user Tom can actually connect to it. So if we did this, we see, access desired for Tom. But what if running as Tom, we try to connect as Dan, we get an access denied message, which is what we wanted. So all that functionality of the multi-instance has been there since MariaDB 10.4, or in a slightly uglier version all the way back to 10.1. So let's move on to the next section. For those who haven't seen, there's also a systemd unit type of sockets. And so what these are, if we do system control list sockets, is we see a bunch of services like cups, dbus, divide messenger sockets that don't need to be running all the time like it may have on a SysV things. However, it's got this aspect of a socket that it's listening on, so that the service can be instigated when it happens. And there's a bunch of those. So if we look at what the MariaDB socket instances are, this is available since like 10.6, just for reference. We see we can do a socket user, a socket group, because we want the socket created as the instance name. We want to be a bit more protective about our permissions. We remove the protection on home. We create an abstract socket here for mainly demonstration purposes. Abstract sockets and file system sockets are supported, and you can have a number of those. What is also here is this MariaDB extra socket service. And what MariaDB and MySQL have had by default is this concept of an extra port, notionally, where you can connect to that port, and if your max connections is maxed out, you'll still be able to connect on this port without getting refused, and it gives the admin the ability to try to resolve that lack of resources status. And this is a feature that's only in MariaDB under the extra under systemd, because it hasn't quite been plugged into for the while. You may have seen those actually roughly look the same, but there's a minor difference actually if we look at the contents of that cat service, and that's this file descriptor name equals extra, and inside the MariaDB code it actually recognizes that and treats it as the special kind of service that it is. So you'll notice at this stage we've actually dropped the reference to the TCP port, and we've done that largely out of laziness, that there wasn't an easy way of grabbing a user ID and in the language of the systemd configuration, converting it to an ID. But all your connectors actually do Unix socket authentications. So what does it look like? Well, let's first stop the current MariaDB at dan.service, and we do that, and if we list that, so the socket's gone, the data directory is still there. Excellent. So what we can do now is we can look at start that service and start the extra, well, I say service, but really I just mean socket. And if we look at system control status on MariaDB at dan.socket, we see that the socket is active and listening. When it's connected to, it will trigger the MariaDB at dan.service, and it's listening on that abstract socket and that file system socket. And that's it. So if we look at what the service looks like now under systemd, we see it's currently inactive. However, it can be triggered by these two socket services because they're started, and that's fine. So let's do that. So let's do MariaDB, and if we do that, we do a connection, and magically it's up and running quite quickly, I imagine you noticed. So what if we do a shutdown now, quit out and look at the status of the service? We see it's still there. In fact, yep, it hasn't shut down. In fact, it restarted in that time. Remember before we had restart always in the service? Now that we've actually got socket activation, we don't actually need that restarted service anymore. So let's comment that out. Shut down service and look at the status. It's inactive and stopped, but it's still triggered, and we'll do that again for fun. That, we can just connect and it automatically starts up. So great. At that point, we're actually relying our users to do the right thing and shut down the service when they're actually finished on it, which isn't really the best way to do it. So let's encourage this environmentalism along a little bit. So remember our template file here. If I paste the right thing, we see that in 10.8 on the branch that I'm currently developing, there's an option for max idle execution time. And this means after 10 seconds of there being no connections and no SQL actually being executed, it will shut down. And it's up to you to decide if 10 seconds is appropriate or whether I'm just using that in my example. So to get into effect, we're just going to remove it there and we're going to stop the MariaDB at dan.service. So this means the next time it'll just populate in. But we've still got actually our socket activation, as we can see from this warning below. So what we can do is we can connect in, and we're going to use the abstract socket for this time. So we can connect in, and we see that it starts in the usual time, and then actually regenerate our configuration file. If we look at the system variables, the max idle execution, the wait timeout, and the interactive timeout, the max idle execution time that we set gets populated through to the wait timeout and the interactive timeout. Now, the interactive timeout is for terminals like this, that if I blabber on enough, it'll actually disconnect. And the wait timeout is for what's used for your normal programming connections, that if you've got connection pooling or something, after 10 seconds, it's going to drop out and you're going to have to reconnect. So hope your applications handle that. Now that I've waffled on for a note, if I do a \s, we can see that it went away as expected. Because it's socket activated, it instantly came back, and we've got an uptime of 0. So if we do a select one, exit out, and show what happens in the status, as it's running, it's still running, still running, still running. Just call this pretend live demo mode. And at a point, it'll be inactive and dead again, all successfully deactivated down the bottom, and it's ready to be connected again when ready. So that's in development thing that for 10.8, but it probably won't make 10.0, it'll probably be 10.9. So how do we make these kind of services permanent? Well, that the instinctive response is to use something like system control enable MariaDB at dan.service. However, that's not quite right, and systemd friendly will tell you that no, it's not right. The essence of it is that socket configurations are there to trigger real services, so we'd enable it like a real service, and that's what we do. And if we look at what the status of, say, libvirt.service is, it's exactly the same. It's got a number of different sockets that trigger the service, and that's what you expect.
Okay, we're back live. So a couple of questions for Daniel from the thing. The first question is, why not Docker containers or something resembling Docker?
Well, I thought this would be kind of an interesting way, and the point of actually doing socket activation is that in the default thing, you've got actually nothing running apart from systemd listing on a few sockets. So that sort of reduces your memory footprint significantly if you're constrained that way. And while there's like Kubernetes and other ways to instigate Docker, there, at least to my understanding, a little bit more complicated. So I thought it'd be fun to do it this way. Want to mention that I'm actually doing the Docker library maintenance of MariaDB as well. So I'm not totally in the dark about it. And yeah, this socket the auto deactivate that I'm working on getting through, in sort of actually plays a role in making containers into that serverless aspect, so they can auto deactivate and in cloud environments start to benefit the low memory use there. So those are the main reasons.
Okay. And next question is, what is the use case for installing MariaDB like this?
Additional flexibility if you've got other requirements or a lot of your workloads already in systemd, and if there's low skills, I guess, in the organization around containers, maybe this is a way to start off the segregation to get either the organization or the company actually used to the aspect that we can actually provide a strong separation on users' databases quite well, and actually hand out privileges and things a little bit more. Maybe you don't quite trust all the users to run up as many containers as they want, or don't know how to control that resource allocation well. The aspect of having it as a service gives a rather limited but flexible capability to run MariaDB in its own config in a number of ways.
Okay. Next question is, users that might want to run their own server still need sudo to make it happen. Any way to move it all into a user instance of systemd?
Yeah, I've thought about user instances of systemd. I just haven't. There probably wouldn't actually be that many changes on that. It's the same sort of thing about removing the start proofs only, and a few of the protect homes and protect systems obviously don't apply in the user instance, but for the most part, the template on how to run a user instance systemd, MariaDB is rather comparable to the one provided.
Okay, that's all the questions there. Any other questions you think people should have asked?
Try to cover most of it. I guess I could do a big talk on FOSDEM and on containers and how MariaDB is developing on those, but I've got a FOSDEM talk on that, and people can wait till next week and go and see that. But
Okay.
but thank you everyone for attending and listening along and asking questions. Much appreciated.
Okay. Thank you very much, Daniel. And
Thank you.
Good luck next week at FOSDEM.
Much appreciated. Bye.